Good morning, dear students. Suppose in you have drawn in a circle, and inside that circle you have drawn a chord. You have drawn this chord AB. Okay, this red one is a chord AB. Okay, whose center is O. Then, as you have drawn this chord AB, then the whole circular region is divided into two parts. One portion is this portion, which is below the chord AB, bounded by this chord and this arc. So this is one circular part of the circular region now, and another portion is above the chord AB, which is bounded by chord AB and major arc AB. This is called major arc. The blue arc is called major arc, and this black arc is called minor arc. This is smaller than this arc. That's why. So if say I mark a point here C, suppose, no, that means this is one circular region where I am rubbing the pen. So you see, this is one circular region. Means the circle is lying on the ground, suppose, and I have joined 2 points of the circle like this by a stick, suppose. Then the whole circular region you have divided into two parts. One is bounded by minor arc ACB and chord AB. Another is bounded by the major arc, ACB, ADB. Suppose I mark a point here D, major arc ADB, and the chord AB. This is the portion. Okay. This portion I am talking about. Clear? Now, this region which is bounded by chord AB and minor arc ACB, that is called a segment. So, if somebody asks you what is the meaning of segment for a circle, then your answer should be like this. So, you will say like this: segment, the region bounded by a chord and a corresponding arc, is called a segment. So that is the definition of segment. Means it should be bounded by chord and arc. Okay, so this is a segment. This is also a segment. One segment is smaller than the other. You can say this is major segment. Okay, major segment, and the other one is minor segment. You can call it minor, smaller than this other segment. That's why it is called minor segment. So major segment, minor segment. Now, dear students, think about a situation where you are asked to find out the area of this segment. Means how much space is enclosed inside, how much plot or region is bounded inside between this chord and arc. This arc and this chord, how much it has bounded. Suppose you have to find out that one. Then you can proceed like this. See, think that we have learned in the previous class how to find the area of a sector. Sector is what? What is a sector? Suppose I join this O which A and B, then I will get a sector here. I am joining radius OA and radius OB. Then I am getting a sector like this. That is sector which angle theta. Suppose this angle is suppose theta. So OACB, this whole thing which looks like this is a triangle and this is a segment. Triangle and segment together a sector. Are you understanding? Because sector's definition was what? The region bounded by two radii and a corresponding arc. Two radii means this is one radius, this is one radius. Bounded by radius, and arc. That region is that is, this whole region is a sector. And inside a sector, there are two things. One is triangle, one is segment. So triangle and segment forms a sector. Clear? So when we talk about the area of segment, that means it is also connected with area of a corresponding sector. That means area of sector means this whole thing minus area of triangle will give us the area of the segment. what I'm saying, you will understand by means of diagram, just by means of using colors. I'm just trying to explain to you. Just you see, dear students, the yellow colored diagram is what? Triangle. Okay, and then the brown shaded diagram, that part of the diagram is a segment. This is segment, this is yellow one is triangle, and the triangle plus the segment, the yellow plus this brown color together, it is a sector. So when we talk about the area of a segment, it is always connected to with the area of sector. So we can say like this: area of triangle AOB, area of triangle AOB plus area of segment ACBA, area of segment ACBA will give us area of sector. Which sector? AOBC. Okay, dear students, so this statement you understand. Now from here I ask you only to write area of segment. Area of segment ACBA is equal to, what will it be? Area of sector AOBC minus area of triangle AOB. This is area of triangle AOB. You understand, dear students? So now let us think about area of sector. We know area of sector. What was the formula we got? That is pi times r square theta divided by 360. No need of putting degree because degree will get cancelled. No need of. So that is area of, this part is area of sector. Minus area of triangle. Area of triangle, half into base of the triangle. For the triangle AOB, we can consider base AB into height of the triangle. Height will be here, just you have to draw one perpendicular from the center O to the chord AB. This is height. So it is height OM. So height OM, where I am just mentioning it here, or okay, you understand. If I write here, I am writing here, since OM drawn perpendicular on chord AB. Okay, this is height of the triangle. So now due to lack of space, I am unable to complete the whole line little better way. That's just I will be continuing with this one. So now we are talking about area of segment. Area of segment is equal to what? That is pi r square theta by 360 minus half into AB into OM. If OM is not given, suppose in a question you are given only the radius, but with the radius it is not enough. Radius and angle is given. How will you know the length of the chord and distance of the chord from the center? OM is what? Distance of the chord from the center. So these two values will be required. Okay, so I am giving you a method to find these two values, value of AB and OM. Since you have learned trigonometry, okay, you will understand it very easily. Just you see, dear students, that part I am giving you here. Look at the diagram, dear students. OA is radius, OB is also radius, and AB is a chord. In class 9, we have come across one theorem. Perpendicular drawn from the center of a circle to a chord bisects the chord. No? If we draw a perpendicular from the center of a circle to a chord, then it will bisect the chord. Because if I draw a perpendicular from here, that means it will bisect the chord. That means M becomes the midpoint of the chord. And when M is midpoint, you have also learned these two are congruent triangle because this is 90 degree, this is 90 degree, then this is common side. These two are equal, so these two angles are also equal. That means this angle will be how much of the whole angle AOB? That will be half. If whole angle AOB, suppose we consider this angle AOB is suppose theta, maybe 80 degree or 90 degree, 60 degree, something like that. This whole angle is suppose theta. Then each part will be half of that theta. That means AOM, angle AOM will be equal to angle BOM. And both will be whose half? Half of angle theta. Means half of AOB. Half of angle AOB. That is half of theta. That is angle AOM. This angle will be half of theta or theta by 2. This one you can write as theta by 2. This angle is also theta by 2. You understand? Now, what is our target? Our target is to know length of AB and length of OM. For length of AB, I can try this way. Concentrate in triangle OMA. Suppose, for your convenience, I am drawing that triangle OMA once again here. Okay. So that you can give attention to that diagram. So this is AM. This is OM. This is OM. And this is OA. OA means it is a replica of triangle OMA. This one I will name the same name I am giving here. This is O because it's duplicate we have taken here. Replica means duplicate. OM here. This is A. What is its length? It is nothing but a radius because this is radius. Now, what is the measure of this angle? This is theta by 2. Theta by 2. Okay. Now, dear students, recall trigonometry. Now, if you want this is hypotenuse, this is 90 degree, this is hypotenuse, this is with respect to this angle, this is base. This is base, this is perpendicular. Sine of the angle, that is theta by 2 means this angle I am saying AOM. Sine of angle AOM is equal to what? Perpendicular by hypotenuse. What is perpendicular for this angle? Because this angle's opposite side is called perpendicular. Perpendicular is AM. And hypotenuse is OA. So, this line only, you concentrate. Sine of angle AOM. Sine of angle AOM. What is the value of AOM? I said theta by 2 because it was a part of AOB. And AOB we will know in our questions it will be given to us. So AOM we will have to write as theta by 2. Okay? Is equal to AM as AM only. OA. What is OA? OA is nothing but a radius. A radius means smaller. Okay? So from this we are getting this R here, taking R here, what will it be? R into sine theta by 2 is equal to AM. This is AM. So AM you got this way. AM is equal to R times sine theta by 2. Remember this. Okay, very, very important. AM we got. But dear students, what is the term here? AB. We need AB. You know that AM and BM both are equal because OM is perpendicular. Perpendicular from the center of a circle to a chord bisects the chord. That is, AB is 2 times of AM because AM equal to BM only. Both these parts are equal means AB, whole AB is 2 times of AM. So what you can say here, AB is equal to, here itself I am writing, okay. AB is equal to 2 times of AM. AB is equal to twice AM, okay. Twice AM, what is its value? R, this one, R times sine theta by 2. So this is the value of AM. We have brought AM here. Now dear students, you got AB. Now you may be thinking, can I cancel this 2 with this 2? No dear students, this 2 is actually telling us to divide the angle, and sine of that, suppose theta is, suppose you have got 90 degree. That means theta by 2 is 45 degree. So when you say sine of theta by 2, then we will understand what? That is, you are talking about sine of 45. When sine of 45. So sine 45 is a ratio only, trigonometric ratio. So this 2 is not cancelable with this because it is telling us the sine ratio of a particular angle theta by 2. And theta is something like that. 90 degree, 60 degree, like that. Got the idea, dear students? So these 2 you don't cancel with these 2. This is just a coefficient here, but this is not a coefficient like that. It is half is not a coefficient here. It is dividing the angle theta. Okay, dear students. So we got AB. AB we got this way. AB is what? 2R into sine theta by 2. Okay. Now when you need AB here, you can substitute that one. What you can write here, if you want to continue after this, you will continue like this. Pi r square theta by 360. This one, degree is not equal, sorry. 360 minus half into AB. Just now we got AB is what? Twice r sine theta by 2. Twice r sine theta by 2. Let us keep it in bracket like this so that we will understand this 2 is not cancelable with this 2. This 2 will be cancelable with this 2 because this is also coefficient, this is also half also is coefficient. We can cancel that. Factors there. So we will cancel later, but we have not yet finished our work. AB is replaced now by this whole expression. Now we will have to replace OM also the similar way. OM, look at the same diagram, same right triangle here, OM. Dear students, OM, with respect to this angle, you will call it base. If you write the cos ratio, I am writing here itself. Okay, dear students, just you see. Dear students, OM, you want OM. Then you write cos ratio, cos of the angle, okay, cos of the angle AOM, angle AOM is equal to base upon hypotenuse, base on hypotenuse, and base is what? OM. Hypotenuse is OA. And as you know, OA is nothing but radius R. R you write here. So what you got? Lastly, cos of angle AOM is equal to OM by R. AOM is what? Theta by 2. cos of angle theta by 2 is equal to OM by R. This RU transpose to the left hand side. What will it be? R into cos theta by 2 is equal to OM. So lastly we got OM also. OM is R times cos theta by 2. That's it. So we got OM this way, R times cos theta by 2. And AB we got twice R times, see AB. AB is twice R times sin theta by 2. Easy to remember. AB is the base of the triangle, twice R times sin theta by 2. It is in sin. And OM, height of the triangle AOB, R times cos theta by 2. Then we can substitute this OM now. We can substitute here. What you can write? OM as R times cos theta by 2. Cos theta by 2. This is for OM. This OM is now substituted. So dear students, look at the whole expression now. Here it is pi r square theta by 360 minus this 2 you can cancel also, no? This 2 and this 2 you can cancel, then it will be like this, r into r square, and here it is sin theta by 2 into cos theta by 2. Dear students, we learned here pi r square theta by 360 minus r square, because this r into this r square into sin theta by 2 into cos theta by 2. So that is area of segment. Don't forget the left hand side part of this whole expression. Area of segment, whatever the name of the segment you give here, say area of segment ACBA. Area of segment ACBA is equal to, I am keeping in a box, is equal to pi r square theta by 360 minus r square into sin theta by 2 cos theta by 2. Here one more step we can extend like this. You have noticed, I think, r square is present here and also here. If we take that r square as a common factor, I am taking r square as a common factor, then it will be what? Pi theta here by 360, easy to remember, pi theta by 360 minus r square is taken as a common factor, then here will be sin theta by 2 into cos theta by 2. This is what? Area of segment. Let us say this is area of segment. So next time you can use this as a formula next time whenever we need area of segment. So dear students, remember this, r square times pi theta by 360 minus sin theta by 2 into cos theta by 2. This is the area formula of segment. Let us apply this in a question just like this. So dear students, we will apply it in a question. So in our questions, this information will be given to us. The angle theta and the radius r will be given to us. Okay. Then we will be asked to find the area of this segment, the brown shaded portion. And in that situation, we will use this formula. That is r square times r square into pi theta by 360 minus sin theta by 2 into cos theta by 2. Let us apply it. Let us take a question. Dear students, I am taking example 3 in page number 228. Okay, example 3, page number 228. Just you see, this is the page number 228 from our textbook, and I am taking example number 3. The way that the book writer has done, that we will not do, we will use our formula now. Okay. So here it is given, find the area of the segment AYB. Diagram is given already, shown in figure 12.9. If radius of the circle is 21, radius is given, and angle AOB, this angle is 120 degree. Okay, radius is given, angle is given. We have to find out the area of this shaded region, that is a segment AYB. Okay, so this is the diagram, example number 3. This is radius. Here this is center, OA is radius, OB is also radius, and AYB is the segment. This angle AOB is 120 degree, that is theta. So here theta is equal to angle AOB, that is equal to 120 degree. This value is 120. Okay, and radius R equal to OA. Radius R equal to OA equal to OB is equal to 21 centimeter. Then theta by 2 you have to find out, because theta by 2 is needed here. Theta by 2 is equal to 120 by 2, that is equal to 60 degree. Now therefore area of segment AYB is equal to, what is the area formula? Just now we have learned R square. We have to learn it by heart. R square times pi theta by 360 minus sine theta by 2 into cos theta by 2. Okay, so R square, R is what here? 21. So you write here 21 square into pi. Value of pi is mentioned in question, 22 by 7. So we'll use it here, 22 by 7. Theta is 120. Use it here, 120 into 360 down there. Okay, minus sine theta by 2. Theta by 2 is 60. You put here 60. Cos theta by 2, that is also 60. So cos 60. Okay, dear students. Now you can cancel this. 0 cancel here. 12 cancels here 3 times. No? Then we will have 21 square into 22 by 21. 7 3s are 21. Minus sine 60. Sine 60 is what? Root 3. You recall, no? Trigonometric table values. That is root 3 by 2. Cos 60 is 1 by 2. So this is 21 square into, inside part let us combine and take their LCM. 22 by 21 minus root 3 into 1 is root 3 by 2 to the 4. So 21 square into LCM is 84. 21 into 4, 84. 21 4 times into 22, 88. Minus 4, 21 times 21 root 3. Let us write it in bracket. 21 square means what? 21 2 times. 21 into 21. Into bracket 88 minus 21 root 3 divided by 84. By this 21 you can cancel this one 4 times. Okay, dear students. 21 4 is 84. Now this 21 numerator, this is denominator. We can keep this way. 21 by 4 aside into bracket this number you write. 88 minus 21 root 3. Okay, centimeter square. This will be the area. Just don't misunderstand this for here. Okay, after cancelling this. So our area that we got 21 by 4 into 88 minus 21 root 3 centimeter square, area of the segment. This is our final answer, dear students. Okay, we can solve all questions like this. Okay, using this formula, area of segment. Dear students, have a nice day. Go through the exercise and examples, all questions. Any question you find difficult, you just email me. I will be helping you out. And have a great day.